Okay, so this is question number 76. Fill in the blanks. A triangle with congruent angles and sides is both blank and blank. Well, we've got a triangle that has congruent angles, so this equals this equals this. Then first of all, they all have to be 60 degrees. And if they also have congruent sides, then this must equal this must equal this. So the first thing that comes to mind is it must be equilateral. And then the next thing that comes to mind is that, well, if it's got three equal sides, three congruent sides and three congruent angles, then it also has two congruent sides and two congruent angles, which sounds a little weird to say, but it makes it also isosceles. I-S-O-S-C-E-L-E. Okay, number 77. A triangle with no congruent sides is called, well, if there's no congruent sides, then it's scalene. Everything's different. Scalene. Okay, a triangle with only two congruent sides is called isosceles. Okay, a triangle with one angle that measures 122 degrees is considered obtuse. So a triangle with one angle that is greater than 90 degrees is obtuse. And therefore these other two angles must be acute. So if this is 122, then these angles combined must be, let's just see, 180 minus 122. That gives us a difference of 58. And so in this case, 58 degrees split between these two other angles means that, you know, it could be anything. One of them could be 1 degree and the other one 57 degrees, but we definitely know that they're both acute. Okay, 80. A triangle with angle P equals 50 and angle Q equals 60 must be, well, it's probably acute because that's the missing one from our list here, but let's just see to make sure. If this is, oh, terrible drawing. Let's go back. Alright, so still pretty bad, but let's just label it. This is 50 degrees. This is 60 degrees. Well, let's try and figure out what this top one must be. So we know that 50 plus the 60 plus, let's just call it x for now, x must equal 180 degrees. So if we combine everything here, we've got 110 plus x equals 180. I'm not going to put the degree sign again. I really shouldn't have done that. If we subtract 110 from both sides, that means that x equals 70 degrees. So therefore we've got 50, 60, and 70 degrees. So they're all less than 90 degrees. So therefore it's an acute triangle. Alright, question number 81. Alright, label all parts of the isosceles triangle. So we know that this is the same as this. Alright, and so this angle up at the top between the two congruent sides is called the vertex angle. Ooh, not an angel, a vertex angle. This right here too at the bottom are called the base angles. Base angle, let me just make that singular. Again, base angle, which I guess makes this the base. Now keep in mind, the base isn't always the one at the bottom, because if we turn this, the base is going to move to the side or up at the top. So just keep in mind the base is opposite the vertex angle, and the vertex angle is between the two congruent sides. These two congruent sides are in fact the legs. Again, keep it singular, leg, leg. Okay, over here, this is a right triangle, so I guess this is a hypotenuse. A hypotenuse is always opposite the 90 degree angle. This is in fact a leg, and this is also a leg. So it's 82. Okay, question number 83. Let's change the color. Let's try some green. The measure of the vertex angle of an isosceles triangle is 110 degrees. What is the measure of one of the base angles? Well, 110 degrees is pretty big. That's obtuse. So our isosceles triangle is looking something like this, where this equals this, and the vertex angle 110 is right up at the top. Now, because this is an isosceles and we're told it, we know that the angle opposite this side, right here, is congruent to the angle opposite this side. So they are the same. We call it x and x. We could now write an equation, something along the lines of, well, 110 plus the x, so those are the three angles, must equal 180 degrees. Okay, I'm going to take off that degree sign. Shouldn't really put that there because this is an equation right now. So here I've got 110 plus 2x equals 180. So now solving this equation, subtract 110 from both sides, I end up with 2x equals 70 degrees. Divide by 2, divide by 2. We now know that x equals 35. So in both of these cases, I can put the degree sign back. I know that x is in fact 35 degrees in both places. So what is the measure of one of these base angles? 35 degrees. And the other one is also 35 degrees. All right. Question number 84. The measure of a base angle of an isosceles triangle is 20 degrees. So let's do this. 20 degrees. So what is the measure of the vertex? Well, first of all, if I'm assuming that this is the setup, two congruent sides, this is in fact in the place of a base angle because it's opposite one of the congruent sides, and so the other angle here must also be 20 degrees. Those are the two base angles. So up at the top now, this must be the vertex angle that we're looking for. This time, let's go a little crazy. Let's call it y. So we know that y plus 20 must equal the 180 degrees. So if I combine my like terms right here, now it gives us 40. So y plus 40 equals 180. If I start to solve this now, I very quickly get to the point where y equals 140 degrees. And that would be my answer for this vertex angle right up at the top. Okay, question number 85. This is asking us to draw the median that passes through BC. So a median is a line that goes from one vertex through the opposite side through its midpoint. And this is pretty important right now. So let's show how to do this. First things first is we need to find the midpoint of BC. So first we're going to put our compass on B, the point. Going to open it up and we're going to draw an arc. And you could continue this in one piece, or you could just do as I just showed right there. And that's our first setup. Next we're going to come across to C. Do the same thing again with the same distance, the same opening. And then what we would do is we're going to connect both of these intersections. So I'm going to connect here through here. And this has now found us our midpoint, which I'm going to try and put a red dot right there on BC at the midpoint. So here it is right here. Now, although we have the midpoint, this line itself isn't the median. It's pretty much perpendicular bisector, but the median itself goes from a vertex, so this corner, this point right here, through the midpoint of the opposite side. So in fact what the median is this red line right here. Oops, little crooked, little off center, so I'll draw it again. Goes from the vertex to the midpoint, and so the red line that you see in the diagram is the median. Alright, question number 86. This is asking for the angle bisector of angle B. So to do this, we need to use our compass again, and we put our point at B, and we're going to draw a little arc right here. Next step, I'm going to show in green. We're going to put our compass point right here and draw an arc. I'm going to show the next step in blue. We're going to keep the compass with the same opening here. I'm going to put the point there, and then we're going to draw an arc here. And finally, I'm going to show us in pink. We are going to connect the vertex of that angle through the intersection that we just created, and that is our angle bisector. Alrighty. 87 is wanting the perpendicular bisector of CA. So we will first identify CA, which is right here. We're going to put our compass on C. We're going to open up the compass and we're going to draw an arc. We'll go something like this. It doesn't really matter if you join up the whole thing, that's fine. Next, going to choose a different shade. We're going to put our compass point on A and then do the same again. Follow it round. Now, as you can see, we've got two intersection points there, and this is not only going to create a 90-degree angle being perpendicular, but it's also going to bisect that segment. So in what you can just see, the orange line is in fact the perpendicular bisector, and we've just created this section here being congruent to this section here. So that was number 87. Okay, 88. 88 is looking for the altitude that is special for each of these triangles. So if you had a compass, you could do this very, very accurately. I'm just going to show with lines right now just to make this a little more simple. Once the altitude that is special for each of the following triangles. So the altitude is going from the vertex all the way down at 90 degrees. This is perpendicular to the line at the bottom. So that's the altitude in the first case. Here's the altitude in the second case. It goes straight down. And here is the altitude in the third case. It goes straight down as well. Alright, next problem. Next problem is 89. 89 asks us to list 4 ways to prove any triangles are congruent, any two triangles congruent. Well, we have the congruency postulates. And the congruency postulates are side, side, side. If you know 3 of the same sides, 3 sides of a triangle are congruent to 3 sides of the other triangle, you know that the 2 triangles are congruent. You also know if you have a side and then the angle between another side are all congruent between the 2 triangles, then they would in fact also be congruent triangles. Also, if you've got a side between 2 congruent angles that are in fact congruent, then you also know that these are congruent triangles. And finally, you've also got angle, angle, side. So 2 angles with a side that's not between them, that would also prove that 2 triangles are congruent. There's also a 5th one here that you could put, which is hypotenuse leg. Okay, question 90, list 2 ways that will not prove 2 triangles are congruent. Well, the first one, take a look at these 2 triangles. Let's say this is equilateral. Okay, and also this one here, let's say that each of these 3 sides are equal. Now, these sides could be 2 inches, 2 inches, and 2 inches. These sides could be 3 inches, 3 inches, and 3 inches. Well, obviously they're not congruent. The sides are different. How about the angles though? Well, in both of these triangles, their angles are 60 degrees, 60 degrees, 60 degrees. Because in every single equilateral triangle, all angles are 60 degrees. So one method that does not prove 2 triangles are congruent is angle, angle, angle. That doesn't prove congruency. What it does prove is similarity. Okay, the next one here is called the donkey rule, and it's angle, side, side. And the reason for that is you could imagine a triangle like this, but then you could also imagine the same side here, and instead of this side coming here, let's imagine it goes out this way. Now in this case, these 2 angles would be the same, so that would be an angle. Also, this side would be the same as this side. And if this side here has just flipped around, then these two sides would also be the same. But obviously this is an acute triangle and this is obtuse, and these two are not congruent, and so the donkey rule, the angle side side rule, does not prove congruency with triangles. Alright, 91. Question 91 is asking us to determine if the two triangles are congruent by using one of my answers from 89. If they are not congruent, write are not congruent. So first thing is we've got to make sure we do this. It's a direct order if they are not congruent. So let's take a look. We've got this matches with this, so that's a side that's the same. We've got an angle here that matches with this angle, so that's an angle. And we've got a side here that matches with a side. So yes, they are congruent, and the method is side angle side. Alright, question 92. Same again, are they congruent or are they not? So here, measure of CBA is right here. This is this thing. And we've got a side matches with a side. We've got an angle right here. Angle matches with this angle. Oh, and we've also got this angle up at the top as well. Let's just check ACB. Almost didn't see this one right there. Angle matches with this one, GIH. So you also have another angle. So yep, they are congruent, and the order that we see are angle, side, angle. It's very important to note this, that the side is between the two angles. So angle, side, angle. Okay, question 93. Let's take a look. ACB is this thing right here. MON, this thing right here. So straight away we know we've got an angle matching an angle, both congruent. We also have 7 and 7 matching side and side, and we also have 8 and 8 matching side and side. Now we've got to be very careful here. The angle is not between the two sides, so this one is the donkey rule, and because this does not prove congruency, we must say are not congruent, or at least we can't say that they are congruent. So 93 is a no-no. Okay, so let's take a look at a right triangle. In this case, let's assume that this is a right triangle. Let's assume that this is the right angle, and let's label some of the other sides. This would be the leg, this would be a second leg, and this would be the hypotenuse. This is obviously the right angle. This here would be an acute angle, and this right here would also be an acute angle, because the sum of these two must be 90, so therefore each of them must be less than 90. Well, state the 4 ways to prove that any right triangles are congruent. Well, the first one is hypotenuse and leg. If you've got two triangles and you know the hypotenuse is the same in both of them, and also one of the legs is the same, then that would prove congruence. Another way is the LA, which is the leg and acute angle theorem. So this is the leg and acute angle theorem, whereas here it's hypotenuse and leg. Well, the leg acute angle is if you have one of the legs and one of the angles, and you know it's a right triangle, then you know that the triangles are congruent. That's because really this is angle, side, angle. Number 3 is the LL, the leg-leg theorem, and in this case we're talking about, we know it's a right triangle, and we know that the two legs are congruent to the two legs on the other one. So this is pretty much the same as the side angle side theorem, but we call it LL, leg-leg, for right triangles. And the next one is the HA theorem, which is the hypotenuse and acute angle. So if you know the hypotenuse and you know the angle, then you also know that the two triangles would be congruent there. And this is the same as having an angle, angle, side. But we call it HA because we know one of the angles is the 90 degrees, and we know the hypotenuse, and we know another acute angle. So that's number 94. Okay, number 95. It's right here. It says determine if the following right triangles are congruent, and if they are, state one of the methods from number 94. Well, I think in all of these cases we're going to assume that this is where the right angle would be. So here we have a leg and we have another leg, and we know the angle between. So whereas you might say this is the same as side, angle, side, for the theorems that we mentioned in 94, this would be the leg theorem between these two right here. Okay, over here 96, we are given a leg and also the hypotenuse, and sure, we know this angle, it's 90 degrees, so this one would be the hypotenuse leg theorem. The hypotenuse of these two right triangles are the same, congruent, and so are the legs, they're the same as well. Alrighty, number 97. 97 says solve for x. Well, in this particular problem, we can see from the diagram that this is an isosceles triangle. It's unfortunate that they called this side, this angle here, x, this point, this vertex x, whereas really they've also called this x. So within an isosceles, the angles opposite the congruent sides are also congruent, and we know the sum of angles in a triangle is 180. So therefore we can come up with an equation, 40 plus x equals 180. So if we combine like terms, we've got 40 plus 2x equals 180. Subtract the 40 from both sides. So therefore 140 over here equals 2x. Divide by 2, and we end up with x equals 70 degrees. And so that's our answer for 97. Okay, number 98. Again, we've got three angles that are labeled. X is what we're trying to find. So we've got 63 plus 57 plus x must equal, well, 180. That's the interior sum of angles of a triangle. When we add these two numbers together, 63 and 57, we end up with 120 degrees. So combining those like terms, 120 plus x equals 180. When we subtract the 120, we end up with x equals 60 degrees. So that's our answer for 98. Number 99. Okay, we're given some notation here. So I'm going to be a little careful. We see that this is our 90-degree angle. So let's label what we have. This one right here, which is w, the measure of angle w is 2x minus 3. This one up there is 3x plus 8. So we could make a couple of equations. One is just to know that this angle plus this angle, w and v, must equal 90, because this is a right triangle and this one equals 90. Or we could just do it slightly the long way, but these three angles must equal 180. So we have w, v, and x. Well, if w is 2x minus 3, v is 3x plus 8, and x is 90, when we add the three of them together, it gives us 180. So at this point, we're going to combine like terms. I'm going to change color for this. We've got the 2x here plus 3x, so that gives us 5x. Changing color again. I've got plus 8 and then minus 3. So 8 minus 3 is 5, and then plus 90 is 95. So that equals 180. So if I continue to solve this right now, I'm going to subtract the 95. So let's make this 5, 17. So that would be 85 over there. And then over here, the 95s would cancel, and we'd bring down the 5x. So now do the inverse operation. So 5 times x, we would then divide by 5, do the same to both sides, and we end up with x equals 17. If this math isn't all that quick, just always remember the first number you say, 85 over 5, the first number goes in the house. The other number outside, 5 into 8 goes 1. 1 5 is 5, subtract, that leaves 3. Bring down, 5 into 35 goes 7. 7 times the 5 is 35, subtract, you get 0. So 17 is our answer there. And so, I'm trying to think, in this case, if they did ask for the missing angles, we would now have to put the 17 in there. 3 times 17, and then plus the 8 over here would be 2 times 17 minus 3. So over here, 3 times that 17, well, 3 10s are 30, 3 7s are 21, so that's 51, plus 8, so that would give us an answer for angle V of 59 degrees. 59 degrees. Over here, that would be 34 minus 3, so that would give us 31. So that would give us an answer of 31 degrees. Okay, that was question number 99. Finally here, in this part, we've got an x on the outside there, which is called an exterior angle. And the trick here is when you have a shape, let's say it's a triangle, and you extend one of these sides, then the angle you create on the outside, right here, let me change the color, the angle you create on the outside is equal to the sum of the non-adjacent angles. Well, right here is the adjacent angle, so we're going to ignore that one, and let's call this y and this one z. So in this case, x, the exterior angle, would equal y plus z. So it's a similar thing over here for this question. We have x on the outside and then these two on the inside. So x equals 62 plus 59. So if we add these two together, we end up with 121 degrees. And that's our answer for number 100.